Let me clip on one for you quickly so you understand. Alright, you basically clip this on over here, you bring your mains in here, and everything below this is now isolated when you drop this, right? Socket outlets have to be on an ELCB. Now what an ELCB is an earth leakage circuit breaker. When it picks up about 30 milliamps, this device will trip. So it trips with tiny amounts of current. Now this is to save human life. This is what this is designed for. It's basically designed to trip before it shocks you to death. Your element of your stove can kind of become live in weird ways. I think regulations state that your geyser has to be on. Obviously your socket outlets have to be on. But to be quite frank, I put on the whole installation on earth leakage. I just split it in multiple earth leakages. So I'll put the geyser on its own earth leakage. I'll put the kitchen on its own earth leakage, and then all the sockets in the house on another earth leakage if there's enough space. If not, I'll just bust them on all on one earth leakage, which is not recommended, but sometimes space is an issue, clients are an issue, time is an issue, and money is also an issue. So all these things taken into consideration. Sometimes I just want the whole thing safe. I don't care if they're in the dark. I just don't want anyone to shock to death. So I'll put everything on earth leakage. Your mains, your earth leakage, and then your 30 amp circuit breaker, which would generally be your stove, 20 amp circuit breaker, which will generally be your geyser, and then a bunch of like 20 amp circuit breakers, which are going to be your socket outlets of your home. And then of course a bunch of 10 amps, which you'll have your light circuits on. Alright, so when you come in on your mains, it'll generally be 10, you jump it with 10 all the way to the bus bar, or you just basically use a rated bus bar for 63. These are how the bus bars look for residential 63 amp installations on Samite rail breakers and the DIN rail circuit breakers. So basically you will have this comb-like thing to jump all the current and the supply through all the circuit breakers through this bus bar safely and without those ugly jumpers, which just are loose connection meccas, you know. So it comes in at the main circuit breaker. Your main circuit breaker can now switch it on and off. The main incomer goes out, comes out to the top, comes into the earth leakage, out the earth leakage, and then obviously onto the neutral bar, which will put all the neutrals on. The live will jump right to the top of the breakers and feed your individual circuits. Alright, so there'll be bust on the neutral bar, all the neutrals will be together, and then your lives will basically come to your comb-like bus bar. Alright, and then distribute through your breakers, which you've now rated at the correct PSC. You've gone to test this. In general, you do a stove with 4 mil because you rate it at 30 amps. You'll do socket outlets at 20 amps. You'll do gate motors normally at 20 amps, and you'll do geysers at 20 amps. 10 amp circuit breakers will be your lighting, will normally be your automation and stuff like that will be normally on a 10 amp circuit breaker. Your PLCs, my whole PLC board is fed actually by a 2 amp circuit breaker. It almost takes no power to relay what it does, because you can do home automation with a bunch of different technologies. I just choose to do it with PLCs because I find them, I've said this before, extremely reliable. If they're using it in a factory that never stops, why wouldn't I put it in my home? You know what I mean? Like, that sounds like the Toyota of home automation. If there's any spaces open, you have to cover them with a blank. The distribution board has to be labeled. You have to label your mains, your earth leakage, your plugs, your geyser, all has to be labeled correctly. Also, before you commission, always double check for circuit breakers.